Okay. I wanted to originally do a demo, but it actually turns out it's kind of hard to show agentic coding. But I definitely have sort of a little bit the urge to share a little bit what I have learned the last couple of weeks. Because I got so many questions about all of it. And by all of it, I mean how I use programming agents. And also maybe to some degree why I'm so hooked seemingly on sort of like the Claude Code kind of version of agentic coding. So you might know me as a Python programmer that has written a lot of open source software. Probably my most well-known ones are the Flask frameworks for the Change-It-To templating engine. The last 10 years, I worked at Sentry on also an open source product. Sentry, the error monitoring tool, turned into an application performance monitoring tool. And I gave a lot of talks over the years, most about engineering and teams and life. But quite frankly, the last months, I fell into a rabbit hole of a lot of AI things. And so in particular, since maybe beginning of May, I just basically am like fully engaged in trying to figure out like agentic programming, let's put it this way. And maybe all of this can be summarized with, I'm recording this at midnight, and just to bring down the point that I sleep a lot less now. A friend called this Claude Code is catnip for programmers, and it really feels like this. I haven't felt so energized and confused and just so like willing to try so many new things since, I don't know since when, but it is really incredibly addicting. And I know from a lot of others that this is not a sort of unique experience for me. The specific subreddits for people that do agentic programming are full of, like almost like a bafflement of like, why is nobody sleeping? Why are we so addicted on this whole thing, right? So keep that in mind. This is really addictive. So what is this thing that is so addictive? Well, agentic coding, and this is really a very recent thing, is sort of a like software development process where AI agents actively participate in the coding process together with you. And so it's a huge shift from things like Cursor or GitHub Copilot, which are primarily targeting towards autocomplete. And I will show this a little bit later, like why there's such a difference between it. But the biggest way of thinking about this is that rather than the AI sort of auto-completing your thoughts, you're kind of in a real-time collaboration between human and AI. And because the collaboration right now is not a form of like you let it run completely detached and everything will just finish, there's an element of back and forth, either through reviews at the end of it or because you're actually kind of observing it as it's going. And particularly with Claude and maybe AMP, you can sort of break down bigger things into sort of tasks, which agents then will do step by step. And to give you some sort of idea of how long these can run, I actually had pretty successful outputs by having Claude Code run for more than 4 hours on a particular pretty big task, which is kind of baffling because like the context that Claude has is not enough to support something like this. But because you can break it down into subtasks which are executed by sub-agents, they can get very good at conserving context and actually not completely destroying everything in the process. And all of this is really all about context. It's like, what kind of data do you give to the agent? How do you make the agent be successful? And so, as ridiculous as it sounds, there's a lot of skill to be applied to agentic coding for it to work better. But really, this is not autocomplete, and I just kind of want to reiterate this as much as possible. And it's also quite a bit further from having sort of the agent sitting in the editor. No, I'll go to it a little bit later. Why are we all of a sudden talking about this? If sort of Cursor's agent mode is around for such a long time, right? Cursor's agent mode is there since, I don't know, I think like a year ago or something like that, I feel like. My suspicion of why it sort of exploded is really, first of all, Sonnet 4 and Opus 4 seemingly have been trained on tool usage. Probably also earlier Anthropic models, but particularly if you're using the underlying APIs, it's pretty clear that no other model currently comes anywhere close to tool usage. At least for the agentic flows, or the kind of tools that you would need for agentic programming. And so there's some indication of this, for instance, also in the documentation. There's a built-in text edit tool or a computer usage tool. Those are hard-coded in the model, so you can supply them on an API, but the model understands how to use those tools, even if those tools haven't been supplied. All right, so it's kind of hard-coded into the learning process. Then the second thing is that Anthropic didn't just provide a model that allows tool usage; they also wrote Claude code, and so there's basically a little agent they can run to try all of this. Yeah. And this has then led to an explosive growth of many more people writing Claude code-inspired agents. I can't even count them at this point. But what really sort of pushed a lot of people towards this is just the incredible value that they're getting out of this. Because if you pay $100 for the base Mac subscription or $200 for the bigger one, for now you can actually now start using these agentic coding tools for much less money than you would have spent if you were to have bought this on an API token by token. So my suspicion is that Anthropic went all in on programming agents, and then we all just piled up on top of it. And clearly a lot of people were aware of this, because the earliest Claude Code clones or alternative implementations, they're going back for months at this point. So if you're using Cursor, or if you heard about Cursor, really is the difference here. Well, the first thing that you should know is that as much as Anthropic called this dangerous, this skip permissions, this flag, and you should really not use it, in practice, I would say 100% of people that I know that are hooked on Claude Code just running YOLO mode all the time. And it's shockingly good at this. Like, it hasn't destroyed my computer, right? It has all the permissions to do really shocking things, but for some reason, they did a really good job that it works really well. Now, there are obviously risks with this. There's for sure the entire topic of prompt injection hasn't been really solved, but in practice, the trade-off seems to be that this works good enough for the projects that you typically would use Claude Code on. Now, it's going to be a problem if people sort of intentionally try to trick you into or trick Claude into doing something it shouldn't be doing. Like, for instance, there can be a GitHub issue that might have some instructions in it that would be problematic. But in practice, so far, it works really well. The second thing is, and so this is quite different from Cursor, because at least last time I tried, Cursor still sort of implies a very low tool limit. It doesn't really like to go for very long. It does have background agents. I'll come later into why they're kind of not really a thing yet. But basically, Claude Code sort of de-emphasizes the editor through its user interface. And I will say that actually, I think that the terminal user interface is not a good user interface. It just happens to be one that's really quite successful right now. And in parts because you can SSH it, you can run it remotely. So it's a pretty good trade-off to support a lot of experimentation. And the experimentation is the really important part, because I've also tried coding agents that do run locally, but that run detached from the terminal. And I find the act of context switching towards the product that these background agents produce just it's just not the same thing. I don't enjoy it nearly as much as I enjoy interacting with a tool like Claude Code or AMP or something like this. So long term, probably this will all look very different. We'll all use background agents, will we use agents in the cloud, all of this stuff. But right now, the sort of like crummy solution that Claude Code provides is just works better in practice. When these systems get much better, this will be different. And I think in parts of what we need to do for these systems to work better will actually be to make the dev environments better, to make the dev tooling better, because the cost of context switching really mostly actually comes down to how quickly can I get the output that the agent produced to run locally so they can interact with it. So it's not just Claude Code, but this is by far my most favorite version of this today. There's Open Code, which is also very, very good, I will say. And it does work with a Claude subscription right now, at least. Then there is AMP, which does use entropic models. And so it is also pretty decent from what I've seen. I think that the cost problem here exists. AMP is, I think that if you're really into programming a lot, I'm not sure that the pricing model of AMP currently makes a ton of sense. I didn't have good results with Codex, but it is also a thing you can use, particularly if you pay for an expensive subscription on the OpenAI side. Gemini CLI, I find to not work at all, honestly. But Gemini is a very, very good programming model. And I'm actually using Gemini CLI from within Claude Code for tricky tasks. And this is also one of the things that works so incredibly well about these programming agents that are just terminal-based. You can trivially nest them. And this is one of the other reasons why I'm not super keen right now on all these editor integrations, because I'm exploring, and having one agent run in another agent is a very cool kind of thing you can try very easily, and is much harder with editor integrations. And just to demonstrate this a little bit, this right now, as I'm recording, is the top post on the Cursor subreddit, which just shows Claude Code. And in fact, I went in the subreddit a couple of times over the last couple of days, and seemingly a third of the posts about Cursor right now are about Claude Code. Now, that doesn't mean that Cursor will, that is a problem for Cursor, but it sort of also reflects a little bit to the experience that I have, and that I also noticed that others did, which is that Cursor effectively degraded, or our use of Cursor degraded to be mostly just a thing we use for reviewing. But the actual work is being done by Claude Code. And the thing is that this, by the time that you might be listening to this recording, it might be heavily outdated, and Cursor has eclipsed Claude Code, right? A couple of months ago, I wouldn't have touched Claude Code at all. I have exclusively used Cursor. My strongest recommendation here is that don't commit yourself to an annual spend. You can get an annual subscription for Cursor right now. Maybe in a couple of months, it's no longer the tool that you want to use. So month by month payment right now beats anything else you can do. The way I use Claude Code really is a little bit like a terminal. I do a lot of things with it that go beyond the programming part. I use it to set up and debug CI. I use it to reconfigure my machine. I make it create and use small tools on the spot. I use it sometimes to browse the internet. And I also use it to create this presentation. And this is important to me because I didn't really do the same thing with Cursor, even when Cursor had the ability to do it. And this comes down to two things. One is that whatever Cursor is doing, it sometimes does things that scare me, and so I don't have a lot of trust in it. It did delete things that it shouldn't have deleted, and its protection seemingly is not as good as whatever protection Claude Code has today. So I feel rather safe with what Claude Code is doing. And so that over time, me using it gives me a little bit more confidence in it. Here's an example of one of the many tasks that I like to do, which is something doesn't work. Previously, what I did is I went and debugged this myself. Now, I just ask Claude. And for instance, I couldn't figure out why Go is on my path. the reason I wanted to figure out why Go is on my path is because when I was triggering the Go build step from within an Xcode project, Xcode didn't see Go on my path. So I tried to figure out, like, what do I have to do to get Go on my path? And then figured out, well, Claude figured out within a minute that there's a system called pathsd on macOS that brought the Go binary on the path. I could have Googled this, I could have figured it out myself too, but it would have taken me way more time, right? And so now this is a question of like 1 or 2 minutes. And even if I'm going Googling myself, which I still do, I will also have Claude do this thing in the background trying to figure out it on its own, and then see who of us comes back quicker. So I want to share a little bit sort of my agentic coding recommendations and what I have learned so far working with them. The first one is simplicity helps. I wrote on my blog earlier that Go is a really good programming language for agentic coding. I've since figured out that PHP is also absolutely amazing at this. Basic Python is also very good. What I call basic Python is there's a lot of Python in its training set that's very, very simple. It's a lot less convoluted than some of the Python code that you would find in the real world in larger applications. So basic Python, for instance, are almost like shell scripts, data pipelines, stuff like this, where basically type information is not all that necessary. Things are very uniquely named. They use a lot of standard library, very few dependencies. All of this works really well. This also points towards the more ecosystem churn there is, the harder something is to use. So for instance, in JavaScript, there is a lot of ecosystem churn, but not all parts of JavaScript churn equally. So I think one of the reasons why React is quite good in these models is because React doesn't actually change all that much. On the other hand, for instance, I still run into problems with Tailwind because sometimes the models sort of get confused between Tailwind 3 and Tailwind 4, and there are actually meaningful differences between them, particularly for the configuration. So the less ecosystem churn you have, the better it works. And I think that is also particularly true, at least from the limited experience I had on a larger code base, that if there are competing patterns within one code base, it doesn't really work all that well for the agent. It will get confused. So you will have to at least provide some more context which patterns are outdated. Last thing here, I actually found that long function names are a really good tool to make the AI be less confused about things. It doesn't quite understand namespaces all the time quite as well. Particularly when working with subtasks, I noticed that giving things more unique names helps it find this information instead of programming it in a second time. It is very easy, unfortunately, right now to use an agent in a way where it will actually duplicate code. And it can also be very hard in reviews to sometimes find this. If you're using agents on existing code base, the most important thing that I can really recommend is that you should absolutely find the time and effort required to improve the quality of your dev environment. Particularly, you should introduce centralized login observability. I will show this later, but basically the quality of your dev environment is really what makes the agent work or not work. You cannot really blame the agent for misusing your tool. It will misuse your tool, and if your tools do stupid things, if you misuse them, then the agent will not be successful. So you really need to build agent-friendly tools. Speed actually here is really important. It is important because, one, if something takes too long, the agent will actually kill it. It often uses timeouts. It tries a whole bunch of stuff. If it sees that the tool just doesn't really work, it will stop using it. That's a problem. I found that spending all the time and effort into getting better login observability is what you want. And observability for agent does not mean OpenTelemetry. Observability for agent means just log files. It means good exceptions. It just means a way for the agent to figure out what's going on, but it doesn't want to have OpenTelemetry. It just wants plain and simple text output. It needs to see the output, and it needs to understand how it gets more output. You have to protect against tool misuse. This is really important. If the tool is used incorrectly, then it should error and should indicate to the agent what went wrong. I give you an example of something that doesn't work very well. If you filter out all the tests from Rust's test system, it will succeed. It will say run 0 tests successfully. That's an example where if the agent sends the wrong test name to the tool, it sometimes incorrectly assumes that the test passed, even though it actually accidentally didn't manage to select the right test. An example of a tool that hasn't been sufficiently protected against misuse. It has to be much clearer that you did something wrong. And you have to find a way for the agent to create scratch tools. So for instance, you can put into your Claude MD file, if you want to try some things, here is how you write throwaway code, where you should place it, how you run the throwaway code. For instance, in Django projects, it can be harder to do this because you might have to configure the Django module correctly. So then you have to provide a way for it to do that. Just test basically once in a project how good Claude is at creating a tool, running a tool. Like if that works, then you're off to a good start. Which also leads me to MCP. MCP, you're probably very familiar with it. It's a buzzword that's everywhere. It gives an agent more tools. I personally use only one MCP. I only use Playwright. Why do I use it? Because it's actually necessary. For everything else, I use command line tools. And this was not the case initially. I used many more MCPs. The problem with MCPs is they all pollute the context. So the more MCPs you have in there, the more of your context you're denoting to just tool definitions. The second thing is that it actually turns out that the agent has, at least Claude Code right now, the underlying models have been trained on basically writing code. So it has in its base model a lot of understanding of how to write code. Comparatively little information does it have about using MCPs. MCPs will be incredibly useful for non-coding agentic use cases. But right now, for coding agents, I don't find them useful. I give you some examples of where I use an MCP and where I don't use anymore. GitHub MCP, I don't use it. I use the GitHub command line tool. Turns out to be more successful. Also because, and this is really important, it can put this tool into another script. And it cannot put an MCP into another script. And so, particularly when it starts to compose larger pipelines, larger tasks that it needs to execute in a row, it will actually write you a shell script in which it uses the GitHub command line tool, which is really, really good. And it doesn't have the same capability if it has to use MCP in between, because the only way in which it can the only way that it has to run MCP is in its main agentic loop. So it doesn't actually know how to interact with an MCP server in a shell script. Another case was I used MCP a lot for bringing documentation in. Documentation overall is a tricky thing because some of the documentation is just too long and it produces a lot of context rot. So what I'm doing now is I'm explicitly providing summaries of documentation that the agent can use, and I give it indication when it should use the documentation. So I pull documentation into a repository where I can reference it. Lastly, one of the MCPs that I used to work with was I wrote an MCP for Gemini to bring other models into it. Right now, what I'm busy doing is I'm using Gemini CLI with Claude Code. That also replaced another use of the MCP for me. I think that this will change. I think there will be a time when MCPs will be much more successful because we will have more context. But right now, for coding usage, I discourage it. Last information here, you as a human cannot use MCP well. It's very annoying to use, in fact. So being able to just use a regular tool that the agent wrote to then also debug it on yourself on your own just beats any form of MCP that can exist. MCP sucks because it, in parts, makes the context much more bloated. This is actually the biggest problem, that you need to get the context down. So one way in which I found this to work really well is to prevent it from spelunking around in a code base unnecessarily. So for instance, in my main Go code base that I have today, I have a tool called make Go methods, which basically grabs effectively through the entire code base and summarizes all the methods that exist. And then I told it to use that tool. And this actually helps it a lot because I've seen what the alternative uses that it has sometimes, where it just rip grabs around in highly inefficient ways. So now it has a smaller thing to go by. I also provided in all my code bases ways to read the last 20 lines of the combined logs, because then I can control a little bit how much output it gets. And I usually guarantee that within the last 20 lines of those logs, the important stuff is. And then I have an information for it if it needs more log, how it gets more log, but it just reduces the total amount of noise. And I also make sure that the logs do not contain things that would confuse it. One good way to use less context is to start using subtasks, sub-agents. At least Claude Code can do that. That requires, in quotes, skill. You can easily make Claude Code run for 12 hours if you want to, but it's not guaranteed that this will actually result in anything positive. So here are some things that I do. I go to O3 on ChatGPT. I iterate with O3 on what a good architecture for problem would be. Then I take that into a Markdown file, put it in a repository, and then have Claude start thinking through that, create a plan how to execute this step by step. Then I will put that into a Markdown file, and then I will try to get sub-agents to work on that. It doesn't always work, but particularly if the kind of thing that you're working on is a prototype or something that you're kind of willing to explore with, where you wouldn't be too upset if the code quality is not amazing, you can let it run for a couple of hours and it will actually work. If you ever get to the point where you have to compact, you're kind of lost. From the moment the compact is run, everything is random. It might work, it might not work, but it's very hard to tell ahead of time if it's going to work or not. So compact is a way for it to compress the context down so it has more context to go. From my experience, when I see I'm running out of context, I just abort and go from scratch. Yeah. Context rot is basically this idea that the context is filled with stuff that can start confuse the AI. Where maybe, for instance, if it tried something, undid it, tried another thing, undid it, tried another thing, undid it, and that is actually successful at the end. If you keep going for too long, it still, in its context, has all the failures too. And so this at times can, for instance, cause it to bring back code it has already deleted, and it should have kept deleted, but it will bring it back. So there are many ways in which this can, in which it can sort of end up in backtracking. And one of the sources for backtracking that I found is when the agent is confused about if it did something wrong or something was pre-broken ahead of time. So particularly the dev environment, if you start giving the agent a task, but the dev environment was actually already not functional, then as part of its solving process, it also has to unbreak the dev environment. And that's a very good way for it to get very confused. It will succeed, but it will basically, it will not make pure forward progress. It will make a detour trying to solve a bunch of stuff, and it will lose a lot of context in doing this. So some examples that I found which are amazing for forward progress is Go has test caching, which basically means you can just tell in a Go project, just run all the tests, and a test that is doesn't need running because it doesn't involve code that has been changed will just not be run. This is great because in comparison, for instance, what we do in Rust is the agent has to explicitly tell it which tests to run, because if it runs all the tests, it gets way too much output. So it will try to select individual tests to run, but then sometimes it selects the wrong test, doesn't get an error because a null selection was made, accidentally sometimes assumes the stuff passed. So not great. Confuses it, sometimes means that it will think that it succeeded, makes some more progress, actually didn't succeed, just didn't manage to run the test, and then goes backtracking and gets all confused because it didn't really fully understand at which point it failed. Okay. Here's some more practical things that I've learned from agentic coding in the last couple of weeks. I alluded to this a couple of times, unified logging. Particularly if I'm working on a web application, I also now forward the console log from the browser window through an API endpoint to the server, and then log it from the server into the same log file as the server logs. Why? Because then the agent can tail the log, and it will see both what happened on the server and what happened on the client, and it has a pretty good understanding in which order it came. Now, it's not perfect, but it's pretty close. And it beats it from trying to then immediately go into playwright and trying to use this tool, because in this case, it might just be able to, for instance, start working on the information that I supplied for my initial failure, right? Because I clicked around in the UI, something didn't work, and it can directly go and look at the logs and figure out what's going on. The second thing is I also try to get the SQL logs in there. Not all the time. I'm trying to trim this down a little bit, and I have an extra SQL log that says, like, here's the full log if you need to look at this. but for it to understand the data flow to the database too is pretty helpful. At all my tools in a Makefile, this is what Claude is pretty good at running. Another thing that's really important is if you have multiple processes, it can be very confusing for Claude to understand how they are being orchestrated, how they work together. I haven't fully managed to solve this problem yet, but I did figure out that the more involved a system is, the more time you have to spend on making it work for the agent to make progress with. This is, for instance, I tried this early on in the Sentry code base when I was still working on Sentry to see how good Claude can understand sending an event from a Python SDK to the UI through the whole pipeline. And unfortunately, it just didn't really fully understand this process. It fell back to a lot of waiting, hoping they will eventually appear in the database, but it just didn't understand how the data flows anywhere through this thing. One way in which I found to at least make a little bit of progress here is I added basically this concept of synchronization points. So I have a utility library in my code base where there's a function called reached. The agent can put reached anywhere in the code base, which basically emits an event. And then it has another way to await the event from the outside. So it can basically have one thing run in the background, do some stuff, and then on the outside, it can await exactly to end up at this point. This is not super amazing in all cases because agents themselves are not very good at doing things in parallel. But it is at least getting rid of this problem that it has to wait for a timeout to kick in. There might be better ways of doing this. Ideally, you can sort of run this in lockstep like a debugger, but I haven't fully had success in this yet. But this is one of the things I'm trying is like how much better can you make these systems work, particularly when concurrency is involved. One thing that, however, works amazingly well is to get Claude to debug your CI. First of all, because you can just sign into a browser and give it access to the browser and have it click around and try to debug CLI this way. But the other thing is that GitHub Actions can be interacted with from the GH CLI tool, which Claude understands. And if you give it in the right instructions, it will debug your application directly in CI. So if you have a problem that can only be tested in CI, you can actually set up an agentic flow where it will do the code changes, but rather than running tests locally, it will make a draft PR, will wait for the draft PR to fail, and only then make progress. So it is absolutely capable of doing that. And so if you, for instance, have like this experience of like, this is a really hard thing to debug, like how do you get CI to pass? Claude can do that for you. It's quite good at this. Lastly, to finish this off, I just want to show you some weird stuff that I did with Claude, just to give you some ideas of what you can do with it. I mentioned this earlier, but my Claude uses Gemini CLI inside. I gave you the instruction of when to use Gemini, mostly just so that it can read PDFs, it can read, it can summarize large context down. How well does it work? Honestly, I don't really fully understand this yet. But I did feel like in certain cases that it does actually does do a pretty good job. The problem is when Claude runs to Gemini, you don't really see what's going on. You will just finally see the output from Gemini eventually when it's done. There's no really streaming involved, so it can look like it's just pausing there for a really long time. But it's definitely one of the things that I want to try more is like getting different kind of agents interact with it. This might also be the case where I do want to use an MCP maybe to see if I can use other models or try more with open code. But today, there's just no good setups for this. Just here thing, this video that you saw earlier in the presentation, just couldn't figure out how to download it, so I just told Claude to do it. It first tried to go to Reddit. It was blocked. Didn't matter. It figured out that the YTDLP tool, it can run via UVX. It just took the URL. It somehow found the video. It extracted the video. And since this presentation is also made just with Claude, it just put it straight into my slides, which is pretty nice. Just recently, I had to sell something on the internet. There's an Austrian equivalent of Craigslist called Willhaben. It's not a problem. You just give it an instruction, you give it the profile where you're already signed in, and it will remote control your browser, and it will put the right description, put the price, put the pictures and everything. It's just fine. Takes out a lot of time. If you don't know how to reconfigure Git, and sometimes I don't know how to reconfigure Git, I just mostly started using Claude to do some really big changes on my system. This was a response to a question that David Kramer had on Twitter about how to reconfigure Git. I actually realized that there are some flags now that can be set that I was unaware of. So I just had Claude flip those flags for me. And I do this for a lot of things. So for instance, I ran out of disk space earlier when I was recording a video, and I just couldn't figure out how to identify the large files in my cache folder. I knew that there would be some, so I just told Claude to just look at this, rank them, try to figure out, like, tell me which of those are probably worth deleting, and off it went, and it gave me a list, and then I made a decision together with Claude what could be thrown away. And yeah, I don't know what's going next, but for me at least, the last couple of months have shown that there's so much power in the combination of an LLM and an agentic loop, and we're just at the beginning of the whole thing. Right now, it feels a little bit like programmers are the first to experience this, but we will not be the last ones. Some of the most interesting agentic loops are just things like deep research, just the combination of Google, result, Google more, result more, summarize. But there's so many things in the real world that we'll be able to somewhat safely automate. So a combination of writing code and just reasoning. And it will be pretty interesting to see where it goes. Right now, I can only encourage people to interact with it more because it really does feel transformative. All right, give me some feedback if this was useful. Otherwise, you find me on Twitter. Bye-bye.